Okay, good morning. Welcome to
FamilyMath1064.
FamilyMath1064. So we are taking a look at a really neat problem that our friend Catriona Agg shared earlier this week. And you actually have gone through and solved this problem already, and I would like you to present your solution. I will, you said you'd do it on the paper, so I'll hold the paper steady while you write. So go ahead.
Okay, so these dots here, it says, are equally spaced along the rectangle's diagonal, and it's asking what's the shaded area. We know that this side length here is 5, and then we have these semicircles which are shaded, and presumably these 2 points are tangent.
Right, that's right.
So at first I called all of these lengths x. Then from power of a point we know that since
just a little, okay.
these two lines both come out of the same point and are both tangent here and here, we know that they're the same length. So we know this length is also 5, and so our x would be 2.5, and the whole length would be 7.5.
Okay, good.
From this, I found the length of the rectangle. So, since this is a right angle, we can use the Pythagorean Theorem. 5 squared plus, I can call this y. Y squared equals 7.5 squared, or I guess 15 halves squared.
Okay. Yeah, I think 15 halves is probably better for... Oops, I zoomed in too much, and you're just a little bit above it, but I fixed it. Okay.
So 5 squared is 25, which is 100 fourths, since the denominator is going to be in fourths here. Plus y squared equals 225 over 4. And so we can subtract 104th from both sides to get that y squared is 125 over 4. And we can take the square root to see y squared is the square root of 125 over 4, which we could call 5 halves times root 5, I guess.
Okay, yeah, that's good. So y is 5 halves times the square root of 5. Alright, nice.
Okay.
So we know now that that length
This
is
y.
5 halves times the square root of 5.
Okay. And then ideally we would want to find the radius of this semicircle, so we can find the shaded area.
Yep.
So I drew in this line, which is perpendicular here, because it's comes off a tangent line.
Yep.
So we have this length is 2.5, this x segment. This length is the radius, r, and then this length is y minus the radius. So y minus r.
Okay.
So again, we can use the Pythagorean Theorem to show r squared plus 2.5 squared equals y minus r squared. So I guess we can write that as 5 root 5 over 2 minus r squared.
Okay, good.
Alright, so r squared doesn't simplify at all. 2.5, we can write that as 6.25, or maybe 25 over 4 would be better.
Yeah, 25 fourths.
Yep. And then this equals 5 root 5 over 2 squared. So 125 over 4.
We can do that from up here.
And then minus 10 root 5, 10r root 5 over 2. And then we're going to have a plus r squared.
Yeah.
And so we can subtract r squared from both sides and subtract 25/4 from both sides, and then move this negative 10r root 5 over 2 to the other side. So we get 10r root 5 over 2 equals 100/4, which is 25. And then, what can we see? We can multiply by 2. Or, yeah. 10 r root 5 equals 50. R root 5 equals 5. And then r equals 5 over root 5, which is just root 5.
Yeah.
Alright, so now we know that r is root 5. These semicircles are the same length because this up here is also ry. So we can just combine them and then use the area formula for a circle of radius root 5. So we get 5 pi
Yeah.
as our total area.
That's a really nice job. So great solution. So in the next video I'll show you a similar way that starts the same way you did and maybe uses a slightly different approach just to show that we can get to the same answer through different ideas.
Okay.